Hi, everybody. Welcome to this talk titled From Pets to Cattle. Today, we'll cover a bit about the history of this concept, which derived from the cloud. And then we're going to talk about how that transfers into desktop and the edge computing world. So let's dive in. My name is Viktor Petersson. I am the co-founder and CEO of Screenly. We essentially do display management. So, sorry. So we do display management, which is basically we do digital signage, which is essentially a fancy word for display management. And that is all these screens you see in the stores with advertisement on, or videos, or dashboard with Grafana on the walls in offices. We have a platform to drive all those screens. And we've done this for about 10 years. And we were one of the first pioneers of using Ubuntu Core. So we started using Ubuntu Core. And last year I did a talk at the summit titled 5 Years of Ubuntu Core, where I go into all the learnings we had over those 5 years. And if you want interested in that, feel free to check that out. And we also have a project called Antheus, which is the most popular digital signage project on GitHub. With Antheus, you can turn any Raspberry Pi into remote managed screen. So for advertisement, for videos, for dashboards. Antheus was started as an open source project, and that's really where we started our journey. We started this on the Raspberry Pi forum back in the days when the first Raspberry Pi came out back in 2013, and we've been growing ever since. Antheus, for those who might be familiar with that, another name for it is Screenly OSE, but it's now renamed to Antheus to make sure there is no confusion between the products because they're very different. We actually last year crossed our 2,000 star mark on GitHub. So super exciting. You start to see the traction of Antheus on GitHub and 2,000 stars, which I think is starting to become a really interesting project. So I'm super excited about everybody who's been helping out with that project and with Screenly at Antheus and both Screenly and Antheus. With that, let's dive into the actual talk. So, oh, sorry, I'm blocking the actual screen. I should probably move myself a little bit from the screen. Pets versus cattle. This is a photo of my dog, by the way. And it's just comparing the whole concept of pets versus cattle. And it all started back in the early 2010s. Oh, sorry. It started around the 2010, and it really helped shift the way from traditional infrastructure to modern cloud infrastructure. And we talk about pets, and maybe the younger people in the audience may not know, I'm familiar with the concept, but pet versus cattle is really the differentiator between two types of views of infrastructure. And in the pets world, you really take care of your servers. You know their personalities. You know their individual treats. You know when something goes wrong, you know how to heal them. And you know exactly how they're configured, their flaws, there are all these intricate details about a given server. And when they get sick, you nurture them back to health. When you need to scale up, you add more of these pets. So you add more of these servers that you all know individually, all their individual flaws. This is a very different approach from the cattle approach, which is what basically paved the way for the new era of cloud computing. And it was largely pioneered by Amazon with EC2s when they first launching that, and when they had ephemeral workers. And they're essentially a commodity, right? So you spin them up and you don't really care about the names. You don't care about anything because they're always ephemeral and you don't really care. And they are not unique. They have no personalities or treatment like that. You don't really know how they're configured because they're all the same. And when they're sick or they break, you delete them and you start over and you don't really care. There's no point in repairing them because you just delete them. And when you scale, you just add more of these. And this is also very important from a security perspective, because if you have these at scale, and for instance, we run ephemeral workers in our entire backend, and that means that they live for 24 hours. So if you manage to get compromised in one of these servers, they'll be wiped in 24 hours anyway. So there's no point in you can't get a persistent threat in there because it's going to be wiped away. And this whole thing paved the way for the movement of Docker and Kubernetes and all these things. Now, how does this translate to the workstation and computing? Well, let's first define what that means. And by ephemeral workstations, or there are plenty of names for it, but what basically that means is that you have some short-lived device, and short-lived can be days to hours, whatever environment. They're stateless, and I would say kind of stateless because they don't have any much state. Everything is usually stored somewhere else. They're very secure for that same reason. So if you manage to compromise it, whatever, with malware, whatever, just power cycling device kind of wipes all those threats and you're back to a clean slate. And this also means when you're operating at scale, you know what the state of these devices are. So they will have a clean slate, much like in the cloud, where you spin up 100 servers, you know they are the same because they have the same source and they derive from the same configurations. And this is very important when you're operating at scale. Now, this is hardly a new concept in the desktop or the workstation world. Back in the early 90s, there was something called reborn cards that were used on workstations. And it was a small PCI card that essentially on boot restored the device to a known state. And I remember vividly these devices because my high school had these devices in all their workstations, and it was incredibly frustrating when you were young tinkering with devices and you power cycle it and it was gone. And this was in the pre-cloud environment. And that meant that if you did not save your work on a network drive, it was all gone, which a lot of people lost their work on because you saved on a local drive and you reboot for whatever reason or the device crash, you lose all that data. Fast forward about 20 years to the 2010 era, so roughly the same time period that the whole pet cattle debate started in the cloud, you start to see the same thing happening on a new wave, and that new wave was the Chromebooks. And the Chromebooks obviously were cloud native ephemeral computing, and a very different concept than the predecessor with the reborn cards. We use extensively Chromebooks at Screenly for that reason, because we know they are safe. We know that you can reboot them and you have a clean slate, and there's really little risk. So all our non-engineers use Chromebooks because you can basically know that they are safe and they're not going to be compromised. So this roughly happened around that time period, about 2010. And today, Chromebooks have essentially taken over much of the educational market that previously relied on reborn cards, for instance. And now, if people were in the talk yesterday about Ubuntu Core desktop, that is essentially going after the same market. And you want to have the same ephemeral state where all the state lives somewhere else, ideally. So it's a movement that started really take shape. Now, what about all these other devices we see in the world, right? So we have everything from ATMs to vending machines to self-checkout counters. They're also essentially desktops, but how are these managed? How does this fit into the equation? Well, if you look at this market, they are largely running either Android or Windows. More often than not, they are already EOL by the time they deploy them. Look at an ATM, for instance, a lot of them are running like Windows XP. If you look at a lot of self-checkout counters, they are running some Android version that is way EOL'd already. So they're essentially pets, and they are highly insecure for many reasons. One of them being the obvious, that they're running an EOL operating system. And they are highly stateful, and they're highly inconsistent because of this state. They are extremely expensive to replace because of all this state, so they're hard to manage and hard to replace. And that means they are just expensive to run, really. And because oftentimes they also lack central management, that means that you don't really know what security updates have been applied to these devices. And security, oftentimes, more often than not, is an afterthought at best. And as a result, you frequently see them in this state. And either this is done for fun, like in the example here, we have somebody took over their entire signage network for their school and been rickrolling the entire school, which is okay, that's kind of funny. But there are a lot more severe consequences to this as well. So the top screenshot you have here is a screenshot from the Muni system in San Francisco, where malware took over all their signage, all their kiosks, and everything, and the entire system grinded to a halt. So, not taking care of this really has real life consequences far beyond just the fun attack vector for rickrolling screens. So we saw this and we started looking at. Oops, I think the screen died. Oh, thanks. So we started looking at this, and what we realized was it doesn't really matter if it's a vending machine, a industrial dashboard, self checkout counter. I'm not sure you can read the diagram; it's pretty small, so it might not be readable from the back. But the bottom line is that you have all these different types of setups, but at the end of the day, they are very much the same. So you have some kind of PC or an SBC running, Android, Windows, whatever. It doesn't really matter. With a set of accessories plugged into it, it might be a touchscreen, it might be a credit card reader, it might be a receipt printer, and then that's connected to the network. So what we realized was, why not generalize this? So we introduced something called Edge Apps, which is essentially sitting on top of Ubuntu Core. So we've been using Ubuntu Core for a very long time, as mentioned before. We have a bunch of snaps. We use Ubuntu Frame on top of this. And then on top of that, we have our Qt wrapper for all of these things. Now, this gives us a lot of benefit out of the box with the security features from Core. And we've also built on top of this a device management platform so you can actually manage that scale, which we use for our regular signage platform. So we have the security, we have the OTA, we have all these things built into Core that we get for free. And this being our vision being here that we want to create a generic screen operating system. Now I use operating system in a very loose term because it's not, strictly speaking, an operating system, of course, but it's a runtime environment more so than anything. And how does that look? Well, the thing is, if you are a bank or you're building an ATM or you're building some sort of application or workload that leverages the screen one way or another, all you really care about is one thing, which is actually top layer here. You care about the business value, which is actually the application running on that screen. Everything else below that, app distribution, the OTA, device management, operating system, all of this is really just busy work. But we've already solved all these problems. We already built the entire stack on top of this. And over the last decade, we've kind of refined that process and built a very reliable system on top of it. We power thousands of screens on this exact stack. And now we're opening up this to developers. And that's kind of the exciting part here. So we built this framework, which is a web-based framework, where it runs locally on that device. And we have a JavaScript library that allows you to tap into the physical world as well. So imagine you have hardware connected to this device. That's how you bridge it. So we can actually build a web environment where you can interface with physical sensors and hardware. This, in turn, allows end users to really focus on what they really care about, which is the actual application, and everything else is taken care of. The security is a big part of this because, as we saw before, a lot of these screens do get compromised, and it does have real-world implications. So we built, obviously, on top of Snaps and Core, when we inherit all those beautiful security elements from there with the confinement and everything. But we also leverage the TPMs very heavily on the devices. So all sensitive data and always like the full description and secure boot all leverage the TPM on the devices. And we have then an ephemeral runtime environment, going back to the state of these devices, we have an ephemeral runtime environment that runs inside that, right? So if you need to have some kind of state, depending if you're building a POS system, you need some kind of state for a temporal state, we can leverage the browser cache for those states. We then have a device manager that sits on top of that. So it's essentially a layer on top of Ubuntu Core that you can manage at scale. We expose all this data either over API or our UI or our CLI. So you can see here like how you can actually probe this using the CLI. We are then adding some beautiful other secure layers on top of that. So we were approached by one of our clients, which is a Fortune 500 company in the US. They needed hyper secure access to their Power BI dashboards. And they had some very strict requirements for what that had to look like. So you could never have any credentials in the DOM whatsoever. Everything had to be fully abstracted away from the browser. So we implemented OAuth 2 client credentials as part of the Edge App framework. And this is super neat, actually, because it's a standard leveraged by Okta, by Auth0, and you can use this to authenticate through third-party services. And the way it works is very straightforward. You basically provide it with some OAuth 2 client credential data, so that's your client key, client ID, and a secret. You then get a bearer token back. You can then use that to authenticate through a third-party endpoint. That could be a dashboard, that could be any kind of web application. So that's something we built over the last few months. And that is something that really resonated well with the enterprise world for security reasons. We then are looking at the future where, because we have all this security on the device itself with the TPM and everything, we have a cryptographic identity on the device. So what we're looking at for the future is to fully enable zero trust. So you can do zero trust applications on top of the Edge App framework and build further on that. So now I want to go into a little bit of a demo, if the demo gods allows me for. Yeah. That's enough, right? Oops. All right. All right, let me see if this works. Oh, okay. Oops. And we can make this larger, I think. And we should probably zoom in a little bit so I can actually read. Is that readable from the back, roughly? Cool. All right. Let's see if my tmux actually works on replicate in that session. All right, that should be readable, right? All right, so how does it work? How do you actually create these Edge apps, right? So we have a CLI that is fully open source that you can check out, written in Rust. And the way it works is very straightforward. So screenlink, oops, Edge app, create, name, hello world. That now has created a few things on disk. It created two files. It's a YAML file, which is basically a definition of the application, and an HTML file, which is essentially an entry point. It's just a static HTML page. So let's inspect this a little bit. So if we look into the YAML file here, we can see we have an IP ID, which is a remote ID. We have an entry point again, which is indexed as HTML, but that could be a remote entry point as well. And then we have a secret, which is, again, very much the same as a setting, but protected in a different way from a security perspective. So let's actually check out the index page. And you can see here, the way it works is very simple. You load a JavaScript file in your web page, and then you can access this using regular JavaScript. And that holds true for secrets. And we're expanding that support to physical hardware as well. So let's say you have a temperature sensor plugged into that device over GPIO. You can read it back the same way using the JavaScript framework. And with WASM going forward, that's going to be even more interesting. So how does that actually look like? So we have a local development environment you can spin up as well. So if you do Edge app run, I have to first create some mock data. So if I do this, oops, I create a new file on disk called mock data, which has, oops, looks like there's some linting missing here, but it's fine. Sorry, there we go. So because you see, we create some mock data here, the host name, the location, all this becomes available by default. And when you run this at scale, you can create, say, a wayfinding device that knows exactly where this device is located, and then map to a destination that is unique. So even if you deploy 1,000 of these, because it knows geographically where the device is, it will be dynamically for all these devices. And then you have other things, so you can be conditioned based on the tags and so on. But let's run this one and see what happens. So if I run Edge app run, I get a URL here. So I'm just going to copy that URL, and then I'm going to bring my browser window over to that side. And as you can see now, this is a very simple edge app, and it shows the various metadata that we have here. Now, I'm going to go and make some changes just to see that it's actually not just static, but actually real. So if I edit the mock data here and actually say, oh, actually my greeting is actually unknown, but it's Cowboy Neil instead, and that I run it again, you can see this updates. And 1 second, I'm just going to pop the new URL over here. And there you go. Oh, there you go. So now that changes. So that's just a dynamic variable in the application. And the workflow is very similar to developing with, say, Cloudflare Workers or Heroku. That's really where we draw the inspiration from heavily. And if we take a step back now and look at why this is important, well, what we've done is to create essentially a runtime environment that can be operating at scale, that is ephemeral, that is using all the security features from Core, and you can really deploy this at scale. And because of this consistency, these security features, we are allowed to properly run this at scale. And it's also future-proof because we have a thesis, and the reason why we're doing this now is because we're very bullish on the future of WebAssembly. We believe that WebAssembly will be the new runtime environment for screens in the future, or a runtime environment for the browser of the future. And already today, the edge app environment is already fully WebAssembly compliant. So you can actually run WebAssembly in this. And our goal and our vision of this is really to make this possible to build everything from a vending machine to a POS system to anything between on top of this environment. And we are looking at various parts. Some of this is open source, some of it isn't, and we are exploring how far we can open source and how much we can open source of all of this. But that's a debate we're having internally, exactly how far we draw that. So the takeaways, like here are some resources, like some of the Playground, for instance, we have on GitHub, has a bunch of these edge apps, everything from clock to weather app to Instagram app, already written, available, fully open sourced. And the developer resource as well, our API, and our CLI is fully open source, written in Rust. You can check it out. And yeah, that's basically it. Do you have any questions on that? Yes.
Well, thank you for a great talk. So what are perspectives for, say, more dynamic orchestration, maybe based on user profile? So I think it's more easily to ask from the concrete example. So if you know what is car sharing, so for example, I'm as a user wish that the car, when I sit in it and rent it, so I know customized for myself, with, I know my favorite radio, my favorite navigator, and so on and so forth. What about like doing it dynamically with this approach?
Yeah, I mean, that's
about real time, or maybe not close to real time of this update.
Yeah, for sure. So it would definitely be possible to drive something that, based on some set of input, would be like some user ID. You would preload all those configurations so that you would have that state living probably server side, and then pull that down and render it locally on the device. But that's absolutely something that I don't see any problem with building that out. But that would be conditional based on user profile input, right? So absolutely, like cars would be difficult because connectivity would be not always there. We built a lot of functionality around offline mode, but it's mostly offline mode for temporary outages, not, let's say, you try to start your car in the forest and it will not load. We have no connectivity, but it's a difficult problem to support both ephemeral environment and also offline mode. But it's an absolutely interesting problem to solve for if you're going forward.
Awesome. Thank you.
Sure. No more question? All right. I don't know what we're doing on time, but yeah. Perfect. All right. Thank you, everybody. Cheers.